On October 19, 2017, Pan-STARRS spotted an object moving rapidly between the stars.
First time ever, an object from interstellar space has been observed to visit our solar system.
In 2017, astronomers spotted some weird thing flying in space near Earth. Upon observation, it was found that this strange object was not from our solar system at all and had entered it recently. It even passed near the Sun and did not behave anything like other planets would have if they came too close to the Sun. For years, scientists could not figure out its origin or the reason it had entered the solar system. But now, after 8 years, astronomers finally think they have found where it came from. So, what is its origin, and should we be worried about anything else flying at us from that direction? The Mystery of Oumuamua. Let's start from the beginning. In October 2017, astronomers in Hawaii spotted something odd using the Pan-STARRS telescope. At first, it looked like a fast-moving asteroid, but it didn't take long before they realized that this thing was not from our solar system. It had already passed the Sun and was racing out into deep space. The object was given the name Oumuamua, which means a messenger from afar arriving first, and it really lived up to that name. Nothing like this had ever been seen before. Right from the start, Oumuamua didn't behave like a regular space rock. Most asteroids or comets in our solar system follow nice, neat elliptical paths around the Sun. But this thing was flying on a hyperbolic trajectory. That means it was just passing through and not stopping, not circling back, just zooming by once and never returning. It came from somewhere beyond the solar system and was already on its way out when we spotted it. The strangest thing was that there was no visible tail. Usually, comets that get close to the Sun heat up and release gas and dust, creating that classic glowing trail. Oumuamua didn't do that. Also, it sped up. You would expect its motion to follow the pull of gravity. But this thing showed a slight, unexplained acceleration. It was not enough to say it was powered or alive or anything wild like that. But it definitely didn't fit the basic physics of how rocks move through space. And then there was its shape. Based on how its brightness changed as it tumbled through space, astronomers guessed that it was not round or lumpy like most asteroids. It was either long and narrow like a cigar or wide and flat like a pancake. Some even suggested it might be spinning erratically, tumbling instead of rotating smoothly. Either way, its proportions were extreme. Some models suggested it could be 10 times longer than it was wide. That's unheard of for natural objects in space. Also, its color is reddish. That matches with a lot of icy objects found in the outer parts of our solar system, like some of the ones in the Kuiper Belt. But that didn't help much in finding out its origin. Scientists used every telescope they could to observe it, including Gemini South, the Very Large Telescope, and even Hubble and Spitzer. But the window to study it was short. By the time people realized how strange it was already fading out of view. So what do we actually know? Its size was somewhere between 100 and 1,000 meters long, depending on how reflective its surface was. That's a huge range, but we cannot do better with the limited light we have. Its speed was also too much. At perihelion, or closest approach to the Sun, it hit nearly 88 kilometers per second, which is about 55 miles per second. The way it moved suggested it had been traveling through interstellar space for possibly hundreds of millions of years. But traveling from where? What was its origin? Oumuamua's bizarre path and strange shape have left astronomers debating for years. And if cosmic mysteries like this fascinate you, hit subscribe, because there are plenty more interstellar puzzles we'll be tracking down. Ready? Let's explore where the Oumuamua came from. The possible origin. Some astronomers tried tracing it back. Initially, it seemed to come from the direction of Vega in the constellation Lyra, which is about 25 light-years away. But when you factor in Vega's movement through space, it turns out the star was not anywhere near that spot when Oumuamua would have passed by hundreds of thousands of years ago. So, no, Vega is not its origin. Others ran simulations that showed it could have come from the Carina or Columba star-forming regions, maybe about 45 million years ago. Still, no one can pinpoint a parent system with certainty. The thing is, space is messy. Stars move, planets get rearranged, and ejected debris like this can float around for millions, even billions of years before crossing paths with anything. So, what are the theories about its origin? The first one is that it's a chunk of nitrogen ice. This theory was presented by astrophysicists Stephen Desch and Alan Jackson from Arizona State University. Their idea was that Oumuamua is a thin, flat shard of solid nitrogen ice blasted off a Pluto-like exoplanet during a collision about 500 million years ago. Why nitrogen? Because it explains everything. Nitrogen ice is super bright. If Oumuamua was made of it, that means it didn't have to be huge to reflect the amount of sunlight we saw. So, instead of being 400 meters long, it could have been closer to 45 by 44 by 7.5 meters. Now, the acceleration. As Oumuamua passed the sun, the nitrogen could have slowly vaporized, pushing the object away just a little. And since nitrogen sublimates quietly without dust or visible gas, it would give that rocket effect without a tail. That fits what we saw perfectly. Desch and Jackson also calculated how often big impacts could knock off these nitrogen shards. Based on how many Pluto-like planets we think exist in the galaxy, the numbers actually work. There could be enough nitrogen ice chunks drifting through the galaxy that it is not too weird we would see one. But not everyone believed this theory. Some scientists pointed out that nitrogen ice would not survive for hundreds of millions of years unless it was ejected relatively recently and came from close by. And no nearby star system lines up well enough to confirm that. Another theory presented was the hydrogen-loaded water ice theory. It was from Seligman and Bergner in 2023. They said that maybe Oumuamua is made of regular water ice, but while drifting through interstellar space, cosmic rays hit it and slowly broke up the molecules, releasing hydrogen gas. Now imagine that hydrogen building up inside the ice over millions of years. As the object gets near the sun and warms up, the heat changes the structure of the ice without melting it, and then hydrogen starts leaking out. Not explosively, but just enough to give it a gentle push. Their math showed that if 0.4 to 800 grams of hydrogen gas escaped per second, that would be enough to cause the acceleration we saw. And that's a believable range based on the size estimates. Hydrogen is also hard to detect from Earth, especially in low amounts, so it would have looked invisible to our telescopes. This model also doesn't require anything exotic like nitrogen ice, but critics pointed out that hydrogen icebergs might not survive that long either. The hydrogen could leak out over millions of years, especially if the outer layer is not sealed perfectly. So there is still some debate about how realistic this is. The third theory was that this object is a fluffy dust blob. This group believed that Oumuamua is a porous, ultra-lightweight cloud of dust and ice like a cosmic cotton ball. It would be so light that solar radiation pressure alone could make it accelerate without needing gas or ice sublimation. That's clever. But to get the acceleration we saw, the object would have to have a density of about 0.001 grams per cubic centimeter, which is fluffier than snow. That's possible, but nothing like that has been seen in space before. Another theory was that it might be a fragment from a planet that got torn apart, maybe by a tidal disruption event or some chaotic collision in a crowded star system. That would explain the flat, stretched shape. If true, it would also mean the galaxy might be full of weird leftovers from destroyed worlds. There is still that idea from Harvard astronomer Avi Loeb. He said maybe it was not natural at all. Maybe it was a solar sail, a piece of thin, flat alien technology built to travel using starlight. He presented his theory, saying that all the natural explanations require material we haven't really seen before. Thin nitrogen ice, frozen hydrogen, and fluffy dust sheets are all possible, but rare and still unconfirmed. Loeb pointed out that if it were a solar sail, it would match the shape, the acceleration, and the lack of gas or dust. It would also explain how it could move in a way that didn't rely on gravity or traditional outgassing. Most scientists said the evidence was not strong enough to make that claim. It is one thing to wonder, another to declare it. But Loeb did not back down. He even published a book called Extraterrestrial, laying out his case that Oumuamua might be the first sign of intelligent life outside Earth. He argued that humanity sends objects like Voyager and New Horizons into interstellar space. So why wouldn't another civilization do the same? Still, until we actually catch one of these things up close, we may never know for sure. But the question is, should we expect another Oumuamua to visit us soon? The next Oumuamua. To answer that, first, we have to know where Oumuamua is now. After its dramatic entrance and even faster exit in 2017, it's long gone. It zipped past the Sun in September that year, got a gravity boost, and then kept flying straight through the outer solar system, past Neptune. And now it is coasting through interstellar space again. Right now, it is somewhere beyond the Kuiper Belt, heading toward the constellation Pegasus at a steady 26 kilometers per second. That's about 94,000 kilometers per hour. And no, it is not slowing down anytime soon. There is no coming back. At this point, even our best telescopes cannot see it anymore. By 2020, it had already faded to the 34th magnitude, so basically invisible. It is too small, too dim, and too far. Tracking it now is like looking for a grain of sand in the dark from across the ocean, and building a mission to catch up is definitely not happening. Several spacecraft concepts were pitched, like the Project Lyra idea, which would have taken 20 to 30 years just to reach it. But nothing ever got green-lit. The window closed fast, but the real question is, will there be another one? Turns out, probably yes. Actually, we might already be missing them. Astronomers estimate that thousands of interstellar objects, like Oumuamua, are drifting through our solar system at any given time. Most are just too small or too faint to be spotted. But in 2019, we did find a second one, 2I Borisov. Unlike Oumuamua, it looked more like a classic comet with gas and dust. That confirmed Oumuamua was not a fluke. These things are real, and they are out there. The problem is that we usually don't see them until they are already halfway through their visit. Oumuamua was spotted 40 days after it passed the Sun. It was way too late to send anything after it. That's why scientists are betting big on future telescopes, especially the Vera C. Rubin Observatory in Chile. Once it is fully operational, it will scan the entire southern sky every few nights. According to early estimates, it could detect 1 to 10 interstellar visitors per year. Some researchers even say up to 70 every year if conditions are right. That's huge. With regular tracking, we would finally have time to spot these objects early, maybe even before they enter the inner solar system. And if that happens, we could actually launch a mission before the object is gone. ESA's Comet Interceptor is already preparing for that. It will sit parked in space, waiting for a surprise visitor. Once something promising shows up, interstellar or not, it will go chase it down. So next time a messenger from afar comes speeding through, we might not just wave from Earth. We might meet it head on. And if it's anything like Oumuamua, we will finally get answers. Or, at the very least, better questions. Now tell us, what's your theory about where Oumuamua came from? Was it really sent by the aliens or just an odd cosmic object? Share your theories with us in the comments below. Before you go, don't forget to subscribe for more cool stories, updates, and things you didn't know you needed to know. Goodbye for now.